Hello students, welcome to the next lecture on the linear algebra. Today we will discuss about eigenvalue and eigenvector. Myself, Dr. Garg. You can simply follow my YouTube channel for finding the various videos on the linear algebra. What is the content of this today's video is? We will see what is the concept of the eigenvalues and the eigenvector and their various applications. Then we will see what is the geometrical meaning of this, and finally we will explain you with the help of some examples. Also, I will tell you some shortcut tricks you can check which is applicable to these examples on this eigenvalue. So first of all, what we have studied so far is we have studied the linear independent, linear dependent. We have discussed about the span. We have discussed about the basis and dimensions. So this eigenvalue is the combination of all these concepts. So that's why this is one of the most important topics in the linear algebra. It has a wide applications. For any of the square matrix, eigenvalues play a significant role in the field of the mathematics, physics, economics, engineering, statistics, and many more. Moreover, if you are from the electrical backgrounds, you have seen about the oscillations which can be predicted with the help of the eigenvalues. Frequency analysis in the digital signals, all are calculated with the help of the eigenvalues and the eigenvectors. Like if you are talking about the sine and cosine wave, you know this is the amplitude which can be predicted with the help of the eigenvalues and the eigenvectors. Now first concept in this eigenvalue is the characteristics polynomial. What is the meaning of that? If you have any of the square matrix of n cross n, then you can define this determinant A minus lambda I, where I is my unit matrix, that is called as the identity matrix. If it is a 3 cross 3, then this is my 3 cross 3. Then if you expand them, this is called as the characteristics polynomial or the characteristics matrix of the A. If you expand them, you will get the nth polynomial of degree, like of this way. Why I have written as a -1? Because you can see if you expand them, it is a -1 raised to power 1. Now here the unknown coefficients C1, C2, what are those? These C1, C2, C3 and Cn, this you can predict it with the help of the coefficient matrix Aij. For example, this is a C1. What is the meaning of the C1 is? C1 is nothing but my A11, A22 plus and so on. That is called as simply the sum of the diagonal entries of the matrix A. So we can say C1 is sum of the diagonal entries, and if we know if this is the matrix, if you add them of the diagonal matrix, what is that? This is nothing but my trace of the matrix A. So you can see the C1 is nothing but my trace of the matrix. Similarly, C2, you can define the C2 as sum of all those entries, where if it is a C2, then we can consider all those principal minors of the order 2. Similarly, Ck, like of the C3, what is the meaning of the C3? Sum of all the principal minors of order k. And what is the Cn? That is nothing but my determinant of the matrix A. We will explain in the couple of the examples as well. Now, how you can define the eigens value? Once you are expanding this determinant, now this is the cubic, this is the nth degree polynomial. Whatever the root of this characteristics equation is called as the characteristics roots, or you can say latent root, or you can say the eigens value. For example, if you have this equation, for example, then can you find the root of this? You can clearly say these are my roots, that is 2 and 1. So these are called as the characteristics roots, or you can call as the eigen value of this product. First of all, the first remark on the eigenvalues, can be the simple. Simple means if you solve them, it has a distinct value, like of this, or -3, 4, 9. Simple means that is a distinct, or it can be of the repeated are. What is the meaning of the repeated? It can be 1, 3, 3, 0, 3, 1, 3, or it can be 1, 1, 1. That's a repeated are. The set of the eigenvalue is called as the spectrum. What is the meaning of that? If you have these values like 1, 2, 3, then if you write as a set 1, 2, 3, that is called as the spectrum. On the other hand, if you have these values 1, 3, 4, then the set is -1, 3, 4 is called as the spectrum. And the largest value, if I say another eigenvalues are say -3, 2 and 1, what is the largest eigenvalue in the absolute. In this case, largest value in the absolute is my 3. This is called as the spectral radius. In this case, what is the largest eigenvalue in absolute is -3. So this is my spectral radius. In this case, 4 is my spectral radius. If you have the eigenvalue like of this 1, 3, 3, then the spectral is, that is a distinct element like 1, 3. This is called as the spectrum of the matrix. That is called as the distinct characteristics roots. Like here, if it is a 1, 3, 3, then you can write as a 1 and 3. Here all are my distinct, you can write as a 1, 3, 4. Now once you have the matrix A, how you can define the eigenvector? That's very simple. First of all, it should be the non-zero, like x can never be a 0. Then the corresponding matrix Ax is equal to lambda x, that is A minus lambda times is my 0. The corresponding value of the x is called as the eigenvector, or called as the latent root or a pole. Again, the characteristics are there. If you have the distinct eigenvalue like 1, 2, 7, then the vector corresponding to this, vector corresponding to this, and the vector corresponding to this are always Li. How you can check the Li? We have discussed 4 different methods. You can watch my previous lecture on the Li, where you can see how you can check whether the vectors are Li or not. If some of the eigenvalues are repeated like 1, 3, 3, then corresponding to this you will get a 1 Li vector. Corresponding to this you will get a 1 vector or 2 vector. It may be 1 or 2 vector, but the combination of them is either Li or Ld. That may or may not be possible. And we have seen in a basis, if I say -2, 1 is my basis, then you can also written this one as -1, 5. These are the same thing, because if you multiply this by 5, then you can get as both have the same thing. So that means if x is my eigenvector, then kx, where k is the non-zero, is also the eigenvector of this lambda. So what is the meaning of that? Eigenvector is not a unit. Now our target is to identify both lambda and x, that is eigenvalue. This lambda is called as the eigenvalue and x is called as the eigenvector. So but here we always look for that Ax is equal to lambda x is always with a trivial solution, but this is no useful in our practical life. So our target is to identify always a non-trivial solution. For example, if I say x plus y is equal to 0, we all know 0, 0 satisfied, but is there any other value? Yes, 1, -1 satisfied, 3, -3 satisfied, -5, 5. So these all are called as the non-trivial solution. So our target is to identify such solution rather than this one. The problem of finding the eigenvalue, that is a lambda, and the x is called as the eigenvalue problem. What is the geometrical meaning of that? If you have this like of where this lambda is the eigenvalue, if you have the vector x, and if I say my lambda is say my positive or lambda is my negative, both can have the things. If it is a positive, then it means you can extend this length by here. If I say lambda is my 3, then you can extend this length by 3 units. If lambda is my 1, you can extend this length by 1 unit. If lambda is my say minus of 2, then instead of the shrinking, instead of the stretch, you have to shrink them like up to here. Then in that case it will be up to this one. Like this is by stretching when lambda is my positive. When lambda is my less than 0, then you have to shrink the length. So it means initially it was here, this is my initial. Then if lambda is my less than 0, then the second case will be my here. So for example, here. So firstly, how you can find the eigenvalue? You can start from here. What is that? What is the I? It's a 2 cross 2. So I is my 1, 1, 0, 0. So I can substitute here 1, -2, 4, -5. This is my A minus lambda times 1, 0, 0, 1. You can find this one. So this is my here. You can find the determinant. This is my here. Plus of 10 is 0. You can open this bracket. It is 4 minus 5 lambda plus of this plus is 0. Sorry, it's a minus. So after solving, you will get as a here. Now how you check whether your answer is correct or not? So in the examination you always check that whatever the eigenvalue you have obtained, remember whatever the eigenvalue of this, the sum of the eigenvalue is always be the trace of the matrix. Second is the product of the eigenvalue is always be the determinant of A. So look at that. What is the sum of this? 5. What is the trace of the matrix? Sum of the diagonal values. So 5 is equal to 5. This property is satisfied. Second is what is the product of the eigenvalue? That's a minus 6. What is the determinant of this? So 4 minus 10 minus 6. Both are satisfied. So it means this is your correct answers. Another shortcut tricks you can verify in your examination that whenever it is a 2 cross 2 matrix, you can write these equations as of this manner: lambda square minus trace of A plus determinant of A always. Remember, this is only for the 2 cross 2. So what is the trace? You can see it's a 5. What is the determinant? 6. You can see this equation is my correct answer. So this is the way you can check in your examinations. So once you can get here, what is the spectrum is? You can see eigenvalues are 6 and minus 1. These are the distinct. The largest eigenvalue is called as the spectral radius. Now you can find the eigenvector. We always start from here, A minus lambda I of x. So firstly we identify corresponding to the 6 and later on with the 1. Since it is a 2 cross 2, our target is to identify this x. So how you can find A minus lambda I can substitute here. The value of lambda is my 6. So you will get as a 5 minus 5 here. Now you can convert this into the row reduced echelon form or a simple echelon form are there. That's on your choice. So what you can do, you can simply take R2, that is R2 minus R1. So you can get as here. So from here you can write as a minus 5x1 minus 5x2 is equal to 0. So from here you can find the value of the x1 minus 2 over 5 x2. Now I can substitute the value of the x1 here. So you can see how many independent variables are there. There is a one independent variable x2, the corresponding value of this. This is my eigenvector. So 0.25, this is called as the eigenvector corresponding to lambda is equal to 6. So this is my here. Or you can also say if you take x2 as a 5, for example, then what is the x2? This is a minus of 5, 2. So this is also the eigenvector corresponding to lambda is equal to 6. So that's why eigenvector is may or may not be a unique. Now we can find the eigenvector corresponding to minus 1. What you can do, we can start from A minus lambda I of x. So lambda is my minus 1, so it is my A plus I. I can substitute lambda is equal to minus 1 in here. So what is that? This will be my 2, it's a minus 2, it's a minus 5, it's my plus 5. So I can write as here. Again, you can operate them. You can write like R2 plus 5 by 2 here. I can simplify them. Now it's a row reduce, so you can see of this. So this is my x1 is equal to x2. So I can substitute here. x1 is x2 means this is my x2, this is my x2. So what is the eigenvector corresponding to them? 1, 1 is the eigenvector. Again, what is the tips for you? You can see the eigenvalues are my minus 6 and 1 are distinct. Fine. So once they are distinct, that means a different, then whatever the eigenvector are there, you can write simple as a matrix here. How you can check in your examination whether your answer is correct or wrong? You can write as a first column, and you can find, if I say this is my B, then the determinant of B is always non-zero. Remember, always non-zero when they are the distinct. If it is a 0, then your answer is wrong. So you can see the determinant is it is minus 1.4, which is a non-zero. It means your answer is correct in the examinations. Now what is the physical significance of these eigenvalues? Suppose I consider another matrix A, and if you find these are my eigenvector. Fine. So what is the meaning of that? This means x1 is equal to x2. This is corresponding to here. And what is that? This is x1 and these are my opposite. Fine. So what is the line of this? x1, this is my line. x1 is equal to x2. x1 is equal to minus x2. This is a line corresponding to my here. Now if I start from here, eigenvalue, if I take a and this is my x, if I multiply them here, can you write 3 comma 3 is either of this form? Yes, you can take 3 as a common, it's a 1 comma 1. If from here, if you take as a 1 common, it's a 1 comma minus 1. Now if you look about this picture, what is my picture is here, there are some pink colors, some are in this same arrow, some are in this direction like of here, some are in the zigzag motion. How you can identify them? So you can see this is the line, the value is my 1, that is you have to, it's a lambda is my greater than 0, positive, so you have to stretch by how much? 1 unit, and for here you have to stretch by 3 units. What is the direction of this? Corresponding to here, what is the direction is? x1 is equal to x2. Which one is the direction? Here, x1 is x2. So it means if I draw this line, then the line of this, that is this blue color is stretched by 3 length of this, like of here. So you can see the corresponding to this, it's a 1. So what it means, if initially this is the length, what is that? This is my x1 is my minus of x2, that is corresponding to here. This pink color is my length corresponding to this line parallel. And what is the dimension of this? It is 1, that is the same length of here. This is the same length. On the other hand, if I consider this one, what is that? This is x1 is equal to x2, that is my here, and the length is increased, this blue color is increased by 3 length of this. While for the red color is some here in this, some in the upside, some in the below side, which can be in the upside. So there is no change in the here. So you can change them in any of the direction. So the length of the purple vector, that is my here, is same because of the eigenvalue 1, while the length of the blue vector is increased by 3 because of the eigenvalue 3. Now look at the one more examples. Now again, how you find the eigenvalue? We can start from a minus lambda is 0. So we can start from here. Now you can expand them. You can see this is my here. Now how you can find the roots of this? Now if you can use the calculator in your scientific, you can use the scientific calculator, you can find the roots of this. But there is another method how you can say, you can see that whether lambda is equal to 1 is a root of this or not. You can see 1 minus 9 plus 15 minus 7, 0 is equal to 0 is here. So how you can say that? That means lambda minus 1 is the root of this. In your lower class you have divide like of this manner, but that will take a very lengthy time consuming. So what is that trick for you? You can write this as a here. What is the coefficient of the lambda cube? 1. Coefficient of the lambda square minus 9. Coefficient of lambda is 15. This is minus 7. Remember, if your equation like of this, for example, so here lambda square is 0, so you have to write here as a 0. Now what is the root is? You have to find 1 is my root. So now you can write the first number as such. Multiply this by this. 1 into 1 is my 1. You can solve. This is my minus 8. 1 into, this is 1 into 8 is a minus 8. It is my plus 7. 1 into plus 7 is plus 7. If this is my 0, then it means this is my root. Now this is my constant value, this is my lambda, and this is my lambda square. So what you can do, you can write this equation as lambda minus 1 is a factor. Now you can write this as lambda square minus 8 lambda plus constant is my 7. So if you divide them, you will get the same answer as here. Now you can see, you can easily simplify that. This is minus 7, this is minus 1 is 0. So what are the roots of this equation? 1, 1, 7 is my roots. If you want to write the spectrum, what are my spectrum? That is a 1, 7, that is a distinct value. And what is the spectral radius? What is the largest value of this in magnitude? Is my 7. Now you can find the eigenvalue. So eigenvector, first corresponding to 1. So there are the 3 cross 3 we have written here. So a minus lambda, I can substitute here as lambda is 1. We can written as here. Now how you can do? You can change them into the row reduced echelon form or simple as echelon form. So I can written as R2 minus R1. You can make them as a 0, here as a 0. or you can make as a shortcut tricks which I explained in the row reduced echelon form. So what is the meaning of that? If I take as x1 plus x2 plus x3 0, you can find the value of either x1 or x2 or x3. That's on your choice. So I can find the value of the x1 minus x2 minus x3. I can substitute here. Now how many unknown variables in this case? How many unknown variables? 2. One is x2 and second is x3. So you can write this as one is x2 and another one is x3. So what are the coefficient of the x2? In the first line is a minus 1, is a plus 1, it's a 0. What is the x3? Minus 1, it's a 0, it's a plus 1 is the here. So these two are my eigenvectors corresponding to lambda is equal to 1. Now there is another value, that's a 7. You can find the eigenvectors corresponding to 7. We can start from the a minus lambda I. I can substitute here as lambda is equal to 7. So it is my minus 5 and so on. Now you can, again, your target is to make this value and this value as a 0. How you can make them? You can firstly make as a 1 and then you can take R2 minus R1 and here. Now you can simply say, you can simply add them, R3 plus R2 you will here. So you can write this as x1 minus here, this is the equation. So from here you can easily find the value of the x2. x2 is my 2 by 3 of here. I can substitute the value of the x2 as here. You can find the value of the x1 in terms of the x3. So you can get the value of the x1 in terms of x3, x2 in terms of the x3. I can substitute here. So this is x3 by 3, x2 is my 2x3 by 3, x3 will be my x3. So there are one unknown variables. We can write this number as, what is that? This is x3 as a outside. So it's a 1 by 3, 2 by 3, 1 is here. So this is my eigenvector corresponding to lambda is equal to 3. Okay, look at the one more example here. So this is my a. You can start from the a minus lambda I here. Now how you can find the determinant? One more shortcut tricks for you. You can see here. Okay, one more case I forget that. Here you can check your answer whether it's a correct or wrong. What is the sum of the eigenvalue? 9. You can see that trace of the eigenvalue is my again 9. What is the determinant of this? What is the product of this is 7. If you find the determinant of this, you will get again as a 7. Okay, so look at the one more example here. Now you can see that this is my upper matrix because diagonal, this below are my 0. So what is the shortcut tricks? You can check the eigenvalues are always of the diagonal values whenever. So the eigenvalues are 1, 1, 1. For example, again if I say 1, 2, 4, 7, 9, 8, 0, 0, 0. So what are the eigenvalues? 1, 7 and 8. Similarly, if I say 1, 2, 3, 4, 5, 6, 0, 0, 0, then again the eigenvalues are my diagonals. Fine. So if I start from the a minus here, you can expand them. You can find the determinant. This 1 minus lambda square minus 0, minus 1, 0 minus 0, and 0 will be 0. So you can see these are my here 1, 1, 1. What is the algebraic multiplicity is? How many times the number repeat? How many times the number repeat? So 1 is repeated 3 times. You can see again 1, 1, 1 are there. What is the sum of the eigenvalue? You can check your answer is sum of the eigenvalue is 3, product sum is my 3. Product of the eigenvalue is 1, determinant of a is also with a 1. Now we can find the eigenvector. Because there is only one eigenvalue, so I can written as a 1 here. I can substitute this value. This is 1 minus 1, 0, 1, 0, 0, 0, 0, 0, 0. Fine. So into x1, x2, x3 is my 0, 0, 0. Now how you can solve that? This is already a row reduced echelon form. So if you solve them, x3, x2 will be 0. So I can substitute here. x1 we don't know, x2 we know, x3. So how many unknown variables are there? There are the two unknown variables. One is the x1, second is x3. So what is the coefficient of the x1? 1, 0, 0. x3 is 0, 0, 1 because there is no x3r here. So we can get as these are my two eigens vector of the product. Because make sure these are my 3 but they are not distinct. So the eigenvector may or may not be Li. May or may not be. Once it is a distinct, then always be the L. So these are the simple three examples are there. We will see the more examples in our next lectures. We will solve these 7 to 8 examples so that you can learn more. Till then, you can simply like, share and comment on my videos. Best of luck students. Happy learning.